A. Gayathri, Associate Professor and Deputy Head, Department of Physics, Amity University. Today we are going to learn about the process called multiplexing. We all know about the process called modulation. After modulation, how this topic multiplexing works. So the modulated, the individual modulated signal, multiple individual modulated signal is transmitted through a single channel to the other end is called multiplexing. Okay. So we all know when we are using satellite communication, not only one earth station will send the signal to the satellite. Multiple earth station will send multiple signal to the single satellite, and that single satellite will resend it to multiple earth station. This is how the transmission works. So all the signals should not get mixed up. Okay, so we are using a single channel in which it is protected. It has a wave band. Okay, so each modulated signal is having a wave band and it is protected and transmitted through a single channel to the other end. Okay, so this process is called multiplexing. Next one is demultiplexing. So the reverse process of the multiplexing is called demultiplexing. So in multiplexing, we are combining all the modulated wave in a single channel. Whereas in the demultiplexing, there will be a receiving end. It receives all the modulated signal and then it will demodulate. It has multiple demodulation. It receives and it is divided into multiple modulated signal, and there will be a demodulator, and then the original baseband signal will be sent to the receiver. So this is how the demultiplexing process works. Okay. Now we are going to see about the different types of multiplexing. So multiplexing is divided into three categories. One is frequency division multiplexing. Next one is wavelength division multiplexing, and the third one is time division multiplexing. Okay. So how this frequency division multiplexing works, let's see. Okay. So now imagine you have 4 or 5 different categories, 5 different channels. So in each channel you want to transmit different signal in different frequency. Okay, so all those frequencies should be modulated and sent through a same channel. For example, many people from Chennai ordering an iPhone. Okay, so that iPhone hub is in Mumbai. Okay, multiple people from Chennai is ordering an iPhone. So do you think that each iPhone will come in separate cargo flight? No, right? Okay, there will be a single cargo flight in the Mumbai. So all the iPhone will be loaded in that single cargo flight, and that cargo flight will come and landed in the Chennai. In Chennai, it will go to a hub where the address will be divided into based on their pin code, and then it will deliver to a particular person. In the same way, all the iPhone which is ordered from Chennai is called different signals. Okay, so that cargo flight is like a channel. Okay, so all those iPhone which is packed will send through a single cargo flight. So this process is called multiplexing. So here in frequency modulation, each signal is modulated with a different frequency so that they will not get mixed up. And also they have a band, protective band in between each. So after that frequency is upgraded and there is protective band, they all loaded in a single channel and it is transmitted. So on the other end of the frequency multiplexer, there will be a demultiplexer where I told you, right, in the Chennai there will be a hub which receive all the iPhone, and based on the pin code they will be separated. The same way, in the demultiplexer, all the modulated signal will be given to the demodulator and the signal will be separated. Carrier wave separately and the baseband signal separately, and it will be delivered to the or given to the receiver end, the corresponding receiver end. So here the frequency plays an important role. The frequency is changed for each signal. So this is called the frequency division multiplexing. Whereas in the wavelength division multiplexing, all the baseband signal or modulated signal will be converted into different wavelength and it is transmitted through a single channel. In time division multiplexing, we are using a sequential thing. For example, my data will be given a word called A. The other person's data or signal will be given a name called B, and then it will be moving through a single channel in a sequential order. A first, B second, C, D. Again A, B, C, D. So each signal will be given in a particular time. for 1 second or 1 microsecond, the A signal will be moving, and the next time it will be B. So on the sequential order, based on the timing, the signal is transmitted. So this is called as time division multiplexing. I hope now you are aware of what is multiplexing and demultiplexing.